Okay, before we go and lose all our time, I want to make sure that you know how to do these problems where you're asked to find the direction of the velocity and the direction of the acceleration for two-dimensional motion. I have this problem called the March of the Penguins. In this problem, the penguin starts from rest at A, waddles just as fast as he can speed up until right here at the end of the platform, hits his belly here, we ignore friction, and we're asked to find the velocity and acceleration vectors at each of those points. Now I've placed a solution to this at the D2L site if you want to go back and review. So the velocity vectors are pretty easy. They're always tangent to the curve. They're always in the direction you're going. If the penguin starts from rest, then by definition the velocity is 0 at A. At B, he's going to the right. Now, he speeds up, 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 cruise control. Okay? So that means the speed at C has to be greater than at B. It's got to be a longer vector. When you go downhill, you speed up, so the vectors get longer. When you go uphill, they get shorter, you slow down. And at H, the penguin turns around and goes back down. So in order to turn around, you've got to stop. Now let's put the acceleration vectors on. When you're looking for acceleration vectors, remember that there are three flavors of acceleration: speeding up, slowing down, and turning. And you can mix some of those flavors. So you ask yourself at each point, which flavors do I have? Well, at A, you're starting from rest. You're speeding up. You can't slow down from rest, and you can't change a direction that you don't have. So that means you have to just speed up. So the acceleration vector would be in the direction of the next velocity a short time later. It would also be tangent to the path. At B, the penguin is speeding up in a straight line. That means the acceleration would be in the same direction as the velocity. At C, the penguin is not speeding up, the penguin is not slowing down, the penguin is not turning, the path is straight, and so that means that the acceleration is 0. At D, the penguin is speeding up and turning right. And that means I need an angle between acceleration and velocity less than 90 and towards the inside of the curvature. You can see that this vector is partially along, that would be the speeding up, and partially perpendicular, that would be the turning right. Okay? At E, we're also speeding up and turning, but this time we're turning to the left, so the vector would be less than 90 degrees, but towards the inside of the curvature. At F, you are not speeding up and you are not slowing down. You were speeding up, you will be slowing down, but F is the point where you take the foot off the gas pedal and reach for the brake. And so at that point, you're only turning, and so you would have an acceleration vector 90 degrees with the velocity. At G, you are slowing down and turning left, so my angle would be greater than 90 degrees and towards the inside of the curvature. At H, I'm coming in before I go the other way. And so just like our bungee cord problem, the acceleration would be back along the path. Check that your neighbor could do one of these problems, because you will have to do one of these problems tomorrow.